Hello and welcome. This is Brendan O'Dowd, C16476404, and this is my solution for the GoGreen Migration to the Cloud assignment part 2. So let's begin. This is the title screen and we'll move it in through now. My VPC details, I have included two VPCs and one will be for production and one will be for testing purposes. Both in the US West 1 edition because that's where the headquarters was based in California. And when I looked on the AWS website, that was West 1 region correlated. The two availability zones are going to be spread across, and I'm going to have 8 subnets in each. So I plan on having 6 private and 2 public. The 2 public are just for the VPC NAT gateway, and another one again to balance the load. Then I've got 2 private web applications, 2 private app ones, and 2 private databases because we don't want anybody to go near our database. And that's for both the production and the test VPC. Security. I've got 4 different security groups. My ELBs, the Elastic Load Balancer, the web, the app, and the database. So for the ELBs, you want to go through 443 through that port, and the source will be the IP address. Then the web tier allows port 8080, which we know is for HTTP. That gets a source from up one step from the ELB. Then the app tier, again 8080 for the port, and that gets that from the web tier. And the database is 3306. Perfect. So I'm going to do that for my database and it's the database port. Other security options. I wanted to include a firewall personally because I thought it'd be good protection at the OS level, an NAC list to protect the traffic at all subnet level, and some Amazon MFA, which is multi-factor authentication where they can send you a code to your phone and then you have to sign in. So just extra secure and extra safe because after all, this is an insurance company and we can't afford to lose any stuff to attackers. Encryption. Encryption. So you want to, based on the requirements, list your options. Encrypt the data set. I want RDS encryption. I want S3 server-side encryption. I want KSM management keys. With them 3 things, I believe they'd be quite safe. And data are in transit, definitely SSL certificate for all the endpoints because I've looked it up on the internet. That's just the best way to do it. My instance details. So include 3. For the web, I want a Linux Ubuntu server. Value will be key value pairs. T2 large will do. And well, it was in the requirements that when the servers are over 74% memory, that they want to drop it down to 50 and 60. And that's why I put 8 instances in because I want this thing banging. The app, Linux Ubuntu as well, same key value pairs. But I'm only using R3 2x large just to deal with all our things because it says here the servers are now at 90%, so to bring that right down to 50 60 we're going to need something bigger than a TTO micro, let's be honest. No, for the database they said they already have a SUSE Linux machine going and that we can't change anything, so we'll keep that the same. We just gave it 2x large, two of them just in case, it works better like that. Recovery strategy. This is pretty handy because, see, servers, they're stateless and snapshots should only be configured on the RDS DB every 4 hours. Another option is just be cost friendly. So what that actually means in English is that every 4 hours a snapshot gets taken of the thing, which is an image that if anything ever any sort of fault goes back, we can go over maximum of 4 hours back and where the problem was not then, and we can go from there. So it's very good. If you do it more often than 4 hours, it's just going to cost you a fortune and you'll be losing money, so there's no point in that. Storage. S3 buckets and Amazon Glacier. These are really 2 good things that Amazon brought out because, see, the S3 buckets they store that at rest and they're really safe and they're spread out across availability zones just to be extra safe. Usually, I thought we would put it here for 3 months to be handy, and then we'd move it after 3 months into the Glacier. They're in 6 months from Glacier, they get deleted from S3 and now the only existing Glacier. If you want to get something back from Glacier, it takes very long with Amazon. And then after about a year or so again, you set the date you want and then it deletes, the information. So that's brilliant storage stuff there. I've got an image here to explain that. the web requirements. Yeah. Basically, the solution for anything to do with peak performance or traffic is going to be autoscalers and elastic load balancers. That's what they're made for. That's what they're really good at doing. Then, to keep our incoming bandwidth between 300 and 750 megabytes per second, I'll get the cloud watching the autoscalers to start up the new servers at 750. And it's at 750 for 5 minutes. When new one's going to kick in, that'll bring it right down. And then just to not waste any money, if it falls under 300 VPS for 8 minutes, then we'll just shut that one down. He'll be terminated. No. So what? So you want the application administrators to get an email when there's 100 error requests, okay, per minute. That's so easy. You can set up a CloudWatch stream that webs the logs from the web service, and you can set an alarm, right? 400 HTTP errors that listens for them, and once it hits a count of 100 of them, you'll get an email to whichever email you enter in the details. The app tier architecture must be flexible and handle peak traffic in performance. So again, as I said, the auto-scaling group can be enabled to scale out and deal with any high traffic or scale back during non-peak hours, to save money. And then the CloudWatch is designed for this, so we can set a rule. So say we want to start up a new application as soon as the memory reaches 80% capacity for 5 minutes at a time and 75% CPU usage respectively. Another rule to say to shut it down if the usage is lower than 30% for 8 minutes. Again, Amazon is all about the cost of things. How are we going to access the internet without patching if you want to expose some servers? Well, what you do is you set up the NAT gateway to the VPC and ensure it only routes non-local traffic. Database. So we want to keep a consistent storage performance of 21,000 IOPSs. To do that, we provisioned an SSD EBS volumes to allow up to 30,000. There's 9,000 extra just in case your thing grows in the next while. So got a decent bit of room there for high availability. I have a master RDBS in one availability zone, a secondary slave one in another one. This will just be the same data copied across, so if one ever goes down, the other one will be kicked right back into action. How do we ensure there's no change in the database schema? We'll just use the same MySQL 5.6.22 engine, and that'll ensure a seamless transition to the cloud. Absolutely. What additional services would I include in my feature? Well, I'd have to say that MFAs I think are really important, and in this day and age, things going on, that they should be as many factors to authenticate a user as possible. Route 53, I'll keep on hearing about this. This is a great thing as well. It's a scalable and highly available domain name system that is great across availability zones. That just links them all together, A, B, C, whatever you have, and it keeps things running smoothly. IAMs, that's just how we access our services through IAMs. We make a user group and things like that. It's extra safety. And that's all I have to say about that. Where's the pod?